All right, so guys, as I was saying now, the shear now is a transformation where along the x-axis, you will have the mapping here will affect your x-axis, right? So if the shear, because as the shear is saying, a shear is a transformation which changes the shape of the figure but preserve the area. Under a shear, a point moves in the direction parallel to the line of the shear. So a shear parallel to the x-axis is given by the transformation. This mapping here, where this indicates that if you're to map your x value and your y value of your pre-image to your image, then the shear parallel to the x-axis will affect the x value in the image. And this x value in the image, you would have to multiply the y value by some value of k. So you would have to add x plus k times the y value. But down here now, the y would go back here, meaning that the shear is parallel to the x-axis. So it's only the image of the x coordinate which is affected, but the y coordinate remains the same. Likewise, down here, if you have a shear parallel to the y-axis, we have the pre-image, which would be this in the column form, xy. And then if you map this now so that the shear is parallel to the y-axis, then the mapping would not affect the image of the x coordinates. So the image of the x coordinate would remain the same. But the mapping would affect the image of the y coordinate because it is parallel to the y-axis. Now, how it affects the y? You would now have to multiply the x by some k value. So you have k times x, and then you add that to y. That's how you get the image of the y. Is that clear, guys? All right, so with that said, let us look at how the examples will look. All right, looking at this now. This one is saying, find the coordinates of the vertices of the image of the parallelogram. All right, now this is a shear. Could you tell me which axis is this shear parallel to? Is it parallel to the x-axis or is it parallel to the y-axis? Guys? All right, so this is.
Both.
Go ahead, Ms. Cabrera.
You look at both.
It looks like both. Not really. It is really not stretching along the x-axis, you know, it stretches along the y-axis, you notice? So if you look, this is a transformation formula that is being used. So what's a transformation formula? If you have this as your pre-image and you write it in column form, xy, that means this will be the x and y coordinates, right? And then now, so this is your pre-image. And your image is what you're going to be mapping it to. So if this is pre-image, then this would be P dash. That would be the image, right? So if you start off with this and transform it to get a dash. Now, this X value here. Notice the X value here has not changed. So up here is still going to have X. But the Y value now is 3X plus Y. All right, now this is a transformation. Now how you work this? For each of these coordinates, you're going to use this transformation on it. So let's say that this is your pre-image. So for A, the pre-image for A would be 1, 1, right? And A dash then, if you use the transformation as given here, you would put back what? You put back the X, so you would put back 1. But for the Y, you would have to multiply the X by 3. So you have 3X, then plus Y. So 3 times 1 plus 1 would give you what? 4. You see that? So that would be the image for A. And so this is where A was. And this is where the image of A is now. So you see I have 1 and 4. Let us do B. So B now would be the pre-image 2 and 1. Right? And so B dash, how are you going to get B dash now? You're using the same formula. You bring back the X value, which is 2. But the Y value, you're going to have 3 times the X plus Y. So 3 times 2 plus 1. 3, 2, 6 plus 1 give you 7. So the image would be 2 and 7. You following, guys? Raise your hand if you're following for me. All right, so you do that for all the coordinates. So if your image for D now, this is your pre-image for D. So D is what? 2 and 3. And so this is D. And if that is D, then D dash can be what? Can somebody tell me what D dash can be? What is D dash?
2.
It's going to be 2 and what?
2 and 9.
So you multiply this 2 by 3, 2, 3, 6, then you add 3, you will get 9. Everybody see that? Hope you did not just look at this up here and give me the answer though. I want you to see the calculation. Is that clear, guys?
Yes.
So this is a shear along the parallel to the y-axis because it is the y coordinates of the image which is affected. So this one has the formula. The top one does not change. You see, you notice we bring back the x values, right? But the y value is what we actually calculate using this part. All right, so any question about that? All right, so that's a shear along parallel to the y-axis. And this one now, this one would be a shear parallel to the x-axis. And you can pretty much see based on which direction they stretch. This one is stretching out along the y, along the x. The other one before was stretching up towards the y. All right. Now, can anybody do the calculation for D dash based on, all right, start with, do the calculation for each of these coordinates for me. So you have them up here. You have A which is 2, 1. So these are your, so let me write the formula. So this is x, y, and this will be the pre-image, and this is the image, and the image is you bring back the x. Oh, you don't bring back the x. you add 2y to the x plus 2y. A second, guys. Let me clear my. All right, so the y coordinates would remain the same. So if you use this calculation with these coordinates, so if you have a, which is 2, 2 and 0, what will this map onto? And this is supposed to be a dash. And b, which is 4 and 0. So I'm just going to ask you to just write these values for me. So you have to work a dash, b dash, and b is 4 and 0. C is 4 and Nobody finish the calculation?
Yes.
All right, what you get for A dash?
Sir, I got 0 and 0.
All right, so for the x value, you would have x plus 2 times the y value. So you'd have 2 plus 2 times 0. Right? So 2